Hello, my dear children. Today we are going to discuss chapter number 3. Chapter number 3, that is coordinate geometry. Coordinate geometry. In this chapter, we are going to discuss these 2 points. What are the 2 points? Introduction introduction of this chapter, and the second one is Cartesian system. Second one is Cartesian system. Okay, my dear children, are you ready to listen the class? Are you ready to get the knowledge of these 2 points, my dear children? Right. You have already studied how to locate a point on a number line. Okay, my dear children, in the first chapter, you have located numbers on the number line. You have also know how to describe the position of a point on the line. There are many other situations in which to find a point we are required to describe its position with reference to more than one line. Okay, my dear children, right. You observe that position of any object lying in a plane can be represented with the help of two perpendicular lines. This simple idea has far-reaching consequences and has given rise to a very important branch of mathematics known as coordinate geometry. In this chapter, we aim to introduce some basic concepts of coordinate geometry. You will study more about these in your higher classes. Okay, my dear children. This study was initially developed by the French philosopher and mathematician René Descartes. René Descartes, the great French mathematician of the 17th century, liked to lie in bed and think. One day, when resting in bed, he solved the problem of describing position of a point in a plane. His method of his method of describing the position of a point in the plane, describing the point in a plane. His method was development of the older idea of latitude and longitude. In honor of Descartes, the system used for describing the position of a point in a plane is also known as the Cartesian system. Okay, my dear children? Right. You have studied the number line in the chapter Number System. On the number line, distances from a fixed point are marked in equal units, positively in one direction and negatively in the other direction. See here, this is the number line. On this number line, we have fixed this point. This is a 0. From this point 0, we marked the equal distances of 1 unit distance. We marked the points on right side and on the left side. On right side, we marked positive numbers. On the left side, we marked negative numbers. Okay, my children. The point from which the distances are marked is called the origin. Then what is this number called? The fixed point is called origin. What is this fixed point called? Origin. Okay, my dear children. We use the number line to represent the numbers by marking points on the line at equal distances. If 1 unit distance represents the number 1, then 3 units distance represents the number 3. 0 being at the origin. So with respect to this point, we locate the point on this number line. Okay, my dear children, the point in the positive direction at a distance of r from the origin represents the number r. The point in the negative direction at a distance r from the origin represents the number minus r. Location of different numbers on the number line are shown on this number line. 1, 2, 3, 4, minus 1, minus 2. Okay, my dear children? Right. Descartes invented the idea of placing two such lines perpendicular to each other on a line and locating points on the plane by referring them to these lines. The perpendicular lines may be in any direction. Okay, my dear children, but when we choose these two lines to locate a point in a plane in this chapter, one line will be horizontal and the other will be, this is horizontal, and we take a vertical line in this chapter. To locate a point on the plane, we have to use a horizontal line and a vertical line. These lines are actually obtained as follows. Take two lines, calling them x dash x, x dash x. This is also number line, this is also number line, but this number line is kept horizontally and this number line is drawn vertically. So let us consider this number line. Horizontal line is called x dash x. We are naming this vertical line as y dash. Place x dash x horizontal and write the numbers on it just as written on the number line. We do the same thing. We do the same thing here also. On the vertical line also we write numbers. Okay, my dear children. Now, if we combine both lines in such a way that the two lines cross each other at their zeros or origins, then the picture become like this. The horizontal line x dash x is called x-axis. This line x dash x, the line x dash x is called x-axis, and the vertical line y dash, the vertical line y dash is called y-axis. Remember these points, my dear children. What is the horizontal line called in this Cartesian plane? X-axis. And the vertical line is called y-axis, and this point is said to be origin. This is a common point. The two axes cross at this point and is denoted by O. Since here, if you observe this side, all the positive numbers are marked, so this is called positive x-axis. Ox is called positive x-axis. Ox is called positive x-axis, and Ox dash is called negative x-axis. Similarly, this part is called positive y-axis, and this part of the vertical line from origin to down is called negative y-axis. If you observe this picture, this plane is divided by these two mutually perpendicular lines into four parts. This is first part. We count from here in anti-clockwise direction. This is the first part, this is second part, this is third part, and this is the fourth part. Okay, my children? Right. Here we are using the words axis and axis. Axis is a singular form and axis is called plural form of the word. We know this horizontal line x dash x is called x axis, and the line vertical line y dash is called y axis. So the both axes are called coordinate axis. Okay, my children, if you observe this plane, these two lines are dividing this plane into four regions or four parts. These four parts are called quadrants. This is the first part, first region. This is second region or second part. This is the third region or third part, and this is the fourth region or fourth part. Especially we use this word quadrant. So we count these regions from OX in anti-clockwise direction. So first region, first quadrant, quadrant 1. This is second region, quadrant 2. Remember these points, my dear children. This region is called quadrant 3 and this region is called quadrant 4. So the plane consists of axes and these quadrants. We call the plane the Cartesian plane. So this entire plane, now this plane is called Cartesian plane or the coordinate plane. The other name of this plane is coordinate plane or xy plane. The other name of this plane is xy plane, or the other name of the plane is Cartesian plane. So Cartesian plane, we call this plane as Cartesian plane or coordinate plane or xy plane, and these x-axis and y-axis are called coordinate axis. Okay, my dear children, remember these points, my dear children. Right. Now come to the point. In this plane I have plotted 4 points P, Q, or S. Okay, my dear children, I have plotted 4 points, namely P, Q, or S. This point for P, if you observe the point P, I have drawn perpendicular line PM and PN on the axis, x-axis and y-axis respectively. If we observe the distance of this point, the distance of this point from y-axis, that is Pn, is equal to OM. Pn is equal to OM. How many units are there? 3 units. So the distance of the point P from y-axis on the positive direction of x-axis or on positive x-axis is 3 units. Similarly, PM, this PM is equal to ON. PM is equal to ON. It is nothing but the distance of the point from x-axis. The distance of the point P from x-axis. How many units it is? 5 units. So this is 3 units and this is 5 units. Okay, my children. Similarly, if you take this point Q, this point Q is at a distance of 3 units, 3 from y-axis, but in the negative x-axis, from the negative x and the negative along the negative x-axis. If we measured along the negative x-axis, and this point is at a distance of 2 units from x-axis along the positive y-axis. Here 3 units, here 2 units. Similarly, the point R is at a distance of 1 unit from y-axis along the x-axis, along the negative x-axis, measured along the x-axis. Similarly, here it is at a distance of CR 1 unit OC or D. So RD, this OC is equal to RD, that is 1 unit. Okay, my children. Now RC, this RC is equal to OD. So this distance is the point R is at a distance of 4 units. 4 units from x-axis along the negative y-axis. Similarly, if you take the point S, if you take the point S, yes, so SE, this is SE, and this is SF. We have drawn perpendiculars on the both axes. So here SE is a distance of the point S from y-axis, on the positive, along the positive x-axis. And here this SF is equal to OE. It is a distance of the point S from x-axis along the negative y-axis. Okay, my dear children. Now, using these distances, how can we describe the points so that there is no confusion? We write the coordinates of a point using the following conventions. Okay, my dear children. So, the x coordinate of a point, the x coordinate, here two coordinates will be there for a point, x coordinate and namely y coordinate. Okay, my dear children. So the x coordinate, we use small brackets. We use small brackets. X coordinate and y coordinate. We write in these brackets. X coordinate and y coordinate. Now to write the x coordinate of this point, how many distance? How many units there from y axis? 3 units. So 3 units, and here 5 units from x axis. These are the coordinates of the point P. Understood this point, my dear children? This point P is at a distance of 3 units from the y axis along the measured along the positive x axis. So we wrote 3, and it is at a distance of 5 units from y axis, from x axis, from here, from x axis measured along positive y axis. So 5 units. Understood, my dear children? 3, 5 are the coordinates of the point P. Here the number, first number is called x coordinate, and 5, second number is called y coordinate. X coordinate is 3 and y coordinate of the point P is 5. Here x coordinate is called abscissa, and y coordinate is called ordinate. Remember these points, my children. X coordinate, this is x coordinate, or abscissa. X coordinate or abscissa, and this is called y coordinate. Y coordinate or ordinate. Okay, my children. Similarly, let us write the coordinates of this point Q. Okay, my children. How many units? How many units are there from y-axis? 3 units, but along negative x-axis. If you measured along negative x-axis, it is at a distance of 3 units from. So along, we measured along the negative x-axis. Okay, my children. So -3. It is -3. The x coordinate of Q is -3, and the y coordinate of this point Q is 2, because we measured along the y-axis, positive y-axis. Understood, my children? This is the point is at a distance of 2 units from x-axis when measured along the positive y-axis. Understood the coordinates of the point Q, minus 3 comma 2. X coordinate is minus 3 and y coordinate is 2. Similarly, come to the point R. Let us write the coordinates of the point R. Then what is the x coordinate here? How many units are there? How far? It is a distance of how many units from y axis along negative x axis measured along negative x axis. How many units? 1. So minus 1 along negative x axis, minus 1, and it is at a distance of 4 units. It is a distance of 4 units from the x-axis measured along negative y-axis. So minus 4, minus 4. X coordinate is 1, minus 1, and the y coordinate is minus 4, because we measured along the negative x-axis and we measured here along negative y-axis. Understood this point, my dear children? The coordinates of the point R. Now come to the coordinates of the point S. How many units distance from y-axis measured along the positive x-axis? 5 units. So 5 units. 5 units. Now how many units distance from x-axis? From x-axis. From x-axis along the negative x-axis. Negative y-axis. Negative y-axis. So minus 2. So 5 comma minus 2 are the coordinates of the point S. Understood this point, my children? How to find the coordinates of a point in this Cartesian plane. Then the coordinates of the point O origin is 0 comma 0. Remember these points, my children. In these brackets, the first number denotes x coordinate and the second number denotes the y coordinate. The first number denotes the distance of the point from y axis, and the second number denotes the distance of the point from x axis. Remember this point, my children. Suppose if anyone asks you how many units of distance of this point q from x axis, we have to take second number y or 2 units. How many units of distance from x axis? 2 units. Y axis 3 units, but measured along negative x axis. Okay, my children. Right. After discussing the previous examples, you observe that the following relationship between the signs of the coordinates of a point and the quadrant of a point in which it lies. See here, in the first quadrant, if a point is in the first quadrant, then the point will be in the form of ordered pair positive comma positive numbers. Since the first quadrant is enclosed by the positive x-axis and positive y-axis, what is the boundaries of this region? OX and OY, both are positive axis. So every point in this plane, is in the form of positive number comma positive number. Understood this point, my dear children? Right. Now come to the second point. If a point is in the second quadrant, then the point will be in the form of negative comma positive. Since the second quadrant is enclosed by the negative x-axis and the positive y-axis, what are the boundaries of this region? Negative x-axis and positive y-axis. So every point in the second quadrant is in the form of negative number comma positive number. Understood this point, my dear children? Right. Now come to the third quadrant. If a point lies in the third quadrant, then the point will be in the form of negative number comma negative number. Since the third quadrant is enclosed by negative x-axis and negative y-axis, what are the boundaries of this third quadrant? Negative x-axis and negative y-axis. So every point in the quadrant 3 is in the form of negative number comma negative number. X coordinate is negative and y coordinate is also negative. And to come to the fourth quadrant, if a point lies in the fourth quadrant, then the point will be in the form of positive number comma negative number. Since the fourth quadrant is enclosed by positive x-axis and negative y-axis, what are the boundaries of this fourth quadrant? Positive x-axis and negative y-axis. That is why every point in the fourth quadrant is in the form of positive number comma negative number. Understood these points, my dear children? The system we have discussed above for describing a point in a plane is only a convention which is accepted all over the world. The system could also have been, for example, the ordinate first and the abscissa second. However, the whole world sticks to the system we have described to avoid any confusion. Understood, my dear children? Right.